very nice good morning to everyone. Myself Adarsh Prakash, where I have completed my BTech from SIT Chennai in 2015. After that, I have completed my MTech from KK University. Overall, I have gained the 3 to 4 years experience in this field, and today I would like to teach you a very good and interesting topic: electric current. In that topic, I will explain each and every term which will help you to gain the good marks and good career growth for your upcoming future. So, my dear, very interesting topic name is electric current. Here, I will explain each and every term from the starting and from the beginning itself. Those who don't have any clear concept, he can also gain the right concept in this topic. My dear, first I would like to ask you what is current and what is the term related here, electric. So, first I will explain the term current. Here you will find that you have listened the term water current, electric current. So basically you will find that the terms related to the current will follow the concept of the flow of things. So what are the things? That is flow of water. That is water. When water is at the rest position, you cannot say that there is water current. Means there should be the flow of water. In the same manner, here is the topic called electric current, and basically, if you will go with the concept of electric, you will find that there is the flow of charge. There will be the flow of charge. So, in your mind, it is you will gain a concept called what is charge. Everybody have understood the concept from the beginning itself. That's the property of matter, which having the attraction and repulsive criteria and property, whatever you call. But the thing is that here it was termed that whenever in the previous time it was seems that if you are taking a atom and just making contact with another atom, it was seems to be given the concept that proton is going to be transferred from one atom to another atom before the discovery of electron. But time has come. It was seems that with the discovery of electrons, it was found that electrons is only responsible for transferring from one atom to another atoms, and that comes under the method of charging that already we have discussed in my previous lecture itself. So here I would like to explain you that basically the flow of charge means you will find the concept of electron, and in electron itself you will find the concept of free electron. So first you have to understand the concept of free electrons. You will find that in any atom, if there is a proton and nucleus, there will be an electron in its outermost orbit, and this outermost orbit consisting of electrons known as free electrons. So here you have understood the concept of free electrons. After going with the concept of free electrons, we need to go with the concept of flow of charge. So flow of charge basically means movement of electrons, that is free electrons. Now we will come to the point. If you are taking any atom, you will find, if you are taking any metal or a conductor, you will find that it consists of a ion, and that free electrons moves their movement inside it, right? So that's why we are saying that flow of charge. Flow of charge who is there only electrons. You are saying that these electrons are going to make a movement inside the conductor or metal. So these ions are basically fixed with each other. That gives the rigidity and signing to the metal. You people know very well. Means there is only a concept that flow of charge is going to take place inside the conductor or metal. After confirming this concept, we are going to just elaborate the concept of current. What is current? And then you are going with the concept of understanding the concept of current, that is electric current. It is represented by a symbol I, and we define it as the rate of flow of charge. Sorry for the inconvenience. Rate of flow of charge through a cross sectional area of conductor. So basically, we will find that electrons is going to be move inside the metal. A lot of electrons are there. There you will find the concept of rate. What is rate? Flow of charge with respect to time. Rate means basically wherever you will find the terms rate in physics, you will find the concept of rate means basically with respect to time. Suppose if you are taking a conductor having a cross-sectional area, here you will find that these are the electrons which is going to be moved from these sides to this side. Another cross-sectional area if you are taking at the same time, you are finding that these are the electrons which are going to move from this side to this side. At a particular instant at time t, you will find that each one rate will be more. You will find that according to the cross section, that's the different things. So we will discuss each and everything with respect to the cross sectional area and temperature, whatever the material nature of material, that's the different thing to it. Just now I will discuss with the concept that at an instant at time t, here at an instant time t also, we will find that more number of electrons are going to flow from this side to this side in this conductor A. Meanwhile, in conductor B, few numbers of electrons are going to be flow at the same time. So rate of flow of electrons is different in different conductor. That depends upon the various factors. We will discuss with that one later on. So here you will find that current I, current is denoted by term I, which is basically equal to rate of flow of charge. So what can you say? Charge is this one. Time is denoted by T. So here you will find the rate of flow of charge through a cross-sectional area. How much current is going to flow at this particular time T? You will say that total charge delta Q is flowing through it and in time delta T. So this you can say that this is your current. The thing is that you have to understand the concept that you are not going to calculate the value of current through a particular electron, particular charge. So over all system, if you are going to calculate the value of electric current for all the electrons, then this value will become known as I average value for the system. Right? So if you will go with the concept of average current, that is equal to delta Q upon delta T. In the same manner, this is the average value of current through the system. In the same manner, if I will say you that at a particular instant of time, if you are going to calculate the value of current, that is known as I instantaneous value. That is instantaneous current, and that value will be considered as dq upon dt. I will also discuss with the same concept. Don't before going to that one, I have to elaborate a little bit concept regarding their unit and regarding their dimension. So before going to the concept, I will discuss with the concept of current. Here, first I will discuss with the unit of current. Unit of current. So, my dear, no need to mug up anything in the physics. Once you have understood the concept, you can get your knowledge. See, current basically is charge per unit time. Now, you people know very well the unit of charge is coulomb, represented by C, and the unit of time is second, represented by symbol S. So basically, you can say that unit of current is will be equal to C upon S, that is equal to CS inverse. This value is also known as ampere. My dear, sorry, my dear, this coulomb per second is also known as ampere. It was the name basically taken at the name of scientist. The ampere was a scientist. That's why we have taken the unit of current as a ampere. Now listen carefully. You will find that in the basic concept, anybody will ask you what is 1 ampere. Then you can imagine itself here itself. You will find that 1 ampere value can be also calculated using the concept of current, that is 1 coulomb upon 1 second value will becomes 1 ampere. So in this concept here itself, you can just define 1 ampere. These are the basic things. No need. Now we are going to with a little bit with your standard. So here, the one more term is there. They will ask you the dimension. What is the dimension of current? So you people know very well dimension of current is represented by basically I's. In some few books you will find that A dash, some few books you will find that I dash. Right? So you can gain the same. Why? Because it current is itself a fundamental quantity. Here you will also find that time is also a fundamental quantity. Charge is not a fundamental quantity, and current itself a fundamental quantity. Now we will go with the concept. We will discuss with the concept of current. Here current unit gets finished. Right. Now we will come with the concept of what type of quantity current is. Basically, there is also a very interesting question may be asked by someone. They will mention you in the concept that it is seems to be found that in so many places and so many, I think very few years ago, it was a question I asked, has been asked. Current, about current. What type of physical quantity it is? Then we will find the concept of that it is a scalar quantity. Now listen the point. A scalar quantity we are saying in spite of this direction, it having the direction, but we are saying it as a scalar quantity. Why? So thing is that you will find that suppose if we are taking this is your circuit in which current is going to flow. I current is flowing through it. This is your resistor. You will find that it having the direction, but direction depends upon the length of the wire, right? Direction is fully dependent on something, and if direction is dependent on anything, then we cannot say that that quantity will be called as a vector quantity, because Vector quantity itself have a specified direction, but current direction depends upon the length of wire. That's why we cannot say it as a vector quantity, right? So in, I think I've given the basic concept regarding this one that was useful for you people. Those who don't have any idea regarding current. After that, we will go with the another concept called direction of current. My dear, direction of current. It is also a basic concept. Don't worry for that one. But I will discuss each and everything. Direction of current. You will find that it is always opposite to the direction of electrons, flow of electrons. Means if you are taking a circuit and you are finding that current is flowing through it, I current is flowing through it from positive terminal to negative terminal, means electron is flowing through negative terminal to positive terminal. Right? So direction of current is always opposite to the direction of flow of electrons. And this is the basic concept regarding the direction of current. Since it has been written in each and so many various types of book, even NCERT also follow the same concept, but there is written a word by convention, right? By convention means what? What you have taken the term by convention, the direction of current is the direction of opposite to the direction of electron, right? Why convenience? Convention means you can say that we have image assumed. Means suppose if you are giving the example that traffic rule, somebody will say that when green signal will takes place, I will pass through it. Somebody will tell like that we will wait for the red light. After that, I will pass from here. Somebody don't care for that one. So that's why they have assumed like that. So in the same manner, by convention, it has been taken into the account. The direction of current will be always opposite to the direction of flow of electron. Right. So this is the next topic. Coming to the next point. Now we will discuss with the concept. After going with the concept of direction of current, we are going to discuss with the current overview. Here, if you will take overview of the current, I will find that current first one is called I average, second one is called I instantaneous. So you will find that average value of current and instantaneous value of current. What is the differences between this one and when you are going to calculate and what type of question you are going to face from this concept? So my dear, before going to that one, first I would like to conclude that I average value, just now I have explained, delta Q upon delta T. Average, why you will take average? Suppose if you are taking a system and the systems, if you are taking as a 5, 6 or any numbers of individuals that having the, suppose you have, I am taking the example that A, B, C, D all are moving inside a system, and in that system they all having the different speed. If you are going to conclude the average speed of A, B, C, D, then you have to, if you want to conclude the speed of that system itself, then you have to take the average value of that A, B, C, D, right? In the same manner, you have calculated the current value with the system in which of very so many electrons are moving, and in that electrons movement, what value of current you are going to calculate in the system will be termed as I average. Here, it will be taken into the account at at a time or till the time, you can say that till the time till the time, that is till time 2 second, till time 5 second, till 8 second, 9 second, like that only. In this manner you will calculate the I average value. Before going to that one, I will use here a concept called quantization of charge. Why I am using such type of word here? Because if you are going to calculate the value of I average, you will find that delta Q value means what? How many charges is going to be flow through the system? That you will know very well. That is Q is equal to NE, where N is the integral number of electrons, integral value of electrons. So here you can say that total charge will becomes delta N E upon delta T, and this is the another value you can calculate. Why I have discussed this concept, you will find that in the same manner you can calculate this value and you can approach the numericals with respect to this formula, and you can calculate a basic calculation of I average with respect to number of electrons, time and charges, right? So here we will discuss with the concept. Suppose if I am taking an example, very good example, if I will take that if 10 is to power 20 electrons is going to be flow through a conductor through a cross-sectional area, then how much current will be flow through that conductor, right? In the same manner, if I will say that if 10 is to power 20 electrons is going to flow through a conductor in 1 second, then what will be the value of corresponding current through the circuit? So you can use this concept here. I average, that will be equal to delta n value. Delta n value means n value, what type of value? 10 is to power 20. Electron value is 1.6 into 10 is to power 19. Time is 1 second. Then you can calculate that it will become 16 ampere. In this manner, you can get the concept of very short type question in the examination with respect to I average calculation. Now listen. In I average calculation, if I am going to discuss with this concept, I will find that how if another type of question you will get with respect to I average value with respect to graph. How? Listen. Here you will find that if I am taking the curve of charge versus time, right? If I am taking a curve of charge versus time, then you will find that at a time t, here if you are taking as a time t2, here is time t1, you will find this value, and this value, that is the second of this curve, I average value will becomes equal to the second second of the curve value at time t1 and t2. Here you will calculate the total current at time t1 and that is at time t2, and that delta I average value becomes delta q upon delta t, that is delta q at time t1 and delta q at time t2, and that difference will become t2 minus t1. And in this manner, with respect to the curve, you can also calculate the value of I average. Now we will go with the concept. After calculating the value of I average with respect to curve, with respect to the quantization of charges, we are going to discuss with the concept of instantaneous value of current. So here we will conclude the instantaneous value of current with respect. Before going to that one, I want to discuss with another type of question that may be asked with respect to the I average value. Suppose if I am taking the charge value is q is equal to 4t plus 2t square plus 3. This is a general equation given, right? I need to calculate the value of current at t is equal to till t is equal to time t is equal to 2 seconds, let it be. So here you will conclude that how we will calculate the value of I average. For that you have to calculate first the delta q value, right? Means till 2 second you will calculate the value of t is equal to 2 second and t is equal to 0 second. So once you will take t is equal to 2 second, value of q will becomes equal to 4 into 2 plus 2 into 2 square plus 3. That will value becomes 8 plus, this is also 8 plus 3, that is equal to 19. In the same manner, at t is equal to 0 second, you will calculate the value of q will becomes equal to 3. So change in delta q is equal to 19 minus 3, and change in time t2 minus t1, that is equal to delta t, that is equal to 2 minus 0 will becomes 16 by 2, that is equal to 8 ampere. So these are the concept, these are the question that may be asked with respect to I average value. Let it be. Now such type of question may be asked with respect to curve, with respect to the little bit in quantization of charge, with respect to the equation of charge given, and you have to calculate the value of average current. Now we will discuss with the concept instantaneous current. So what is the value of instantaneous current? Here we will discuss with the concept of instantaneous current. See, here instantaneous current value means what? Value of current at a particular instant of time. So in that one, same concept, whatever you have calculated with respect to the I average value, here we will going to be discussed with the concept of I instantaneous value will becomes equal to dq upon dt. So this is the basic terms how you will calculate. I will let you know what type of numerical you will face regarding instantaneous current value. So first I will discuss, suppose if I am going to take an example equation type. Suppose I am taking the example of suppose I am taking any example of q with respect to like 4t square plus 2t plus 3. I am taking an example of value of charge, that is equation of charge. Next, here if I want to calculate the instantaneous value of current at t is equal to, same previous type of example I have taken, as t is equal to 2 seconds. Then we will go with the concept at t is equal to 2 seconds. I have to calculate the instantaneous value of current. What I have to do first? Go with the concept dq upon dt. There is the t. With respect to t, you have to differentiate the equation. You will get the value, and in that you have to substitute the value of t. You will get the instantaneous value of current. So what you will write? 4. Sorry for the this one. 4 t. Don't go directly because you may do mistake. T square differentiation is 2t. 2t differentiation is 2, and the 3 differentiation is 0. That is your dq upon dt. Now listen. Once you have calculated this term 80 plus 2, then you can go with the concept 80 plus 2. 80 plus 2 is your dq upon dt. Here you have to substitute at t is equal to 2 seconds. So what will the value? 8 into 2 plus 2, that will becomes equal to 18 ampere, and that is your instantaneous value, right? Same manner, if they will ask with the I average, what you have to do at t is equal to 2, first you have to calculate the substitute 2 is t is equal to 2 value in this equation and get calculation for that one, and at t is equal to 0 get calculation for that one, take the difference of that one, that is delta q upon delta t. That value will gives you the value of I average. So this is the concept of instantaneous value of current. How you will calculate the instantaneous value of current, regarding that one I have discussed this one. Now this was the concept regarding the equation type waste numericals. Now I'm just going from the basic itself, so don't worry for that one. It's quite tough for me in this session. I am not available at the center. Now listen. Here we will go with the concept of another type numerical waste, that is depends on the curve, right? So what you will find that if I am taking an example of a versus time curve, charge versus time curve, what you will find that at a particular instant of time, if you will draw the tangent, that is the tangent will gives the instantaneous value of current at a particular instant of time, right? So with respect to curve, if you want to calculate the instantaneous value of current, you have to go with the concept of slope of the tangent. Slope of the tangent will gives you the value of instantaneous value of current, right? In this way, I have concluded the topic instantaneous curve value of current and average value of current with respect to the curve line, with respect to the equation, and with respect to the quantization of charges. We will discuss with the next concept in this topic. Discuss with the next topic, and very interesting topic. There might be a question may be asked in upcoming future. So be ready for that one concept. I will go with the concept called current density. So my dear, first you have to understood the concept of current density. You will find that it is represented by a symbol say, and as it is a vector quantity, that's why I substituted the arrow marks on its head. Right? These are basic things. You understood the concept of vector notation. So here I will give you the concept of current density with respect to two types of definition. Why I am discriminating that one, you will understood the concept little bit. Wait, you have to there, right? So first one I will go with the concept. Current density has magnitude, and that magnitude value is equal to current per current per unit area right, in the region surrounding to the point itself, right, and the direction will be along the direction of current. Now listen very carefully what I have said. First one, current density value will becomes equal to, suppose if current is flowing through this region, right, and meanwhile I have taken into the account a particular area through which it is going to be pass, right. This area, if I will note it as a dA, little area, right. The same manner it will cover the little amount of current, and that current value will becomes dI, right. So as per the definition, you will go with the concept of value of current density will become dI upon dA, and that direct current density direction will becomes the direction of current as same, right. So this is the first one. In another case, if you will go with the concept, you will find that just I will change a little bit to the definition. You will find that current density magnitude depends upon current per unit area that is perpendicular to the region current flowing through it. Right? What I have said, there I have changed a little bit. Right? Taken into the account that is going to be perpendicular to the direction of current. See, here is the current flowing. Now I will take the particular area that is going to be perpendicular to the direction of current, right. Now listen, in the same manner, if I will take into the account, what you will find, suppose I am taking this particular area. Now you will feel here, what you will feel, it is the perpendicular to the surface. It is going to be perpendicular to the direction of current. Direction of current, if it is going to be perpendicular, then you can get the value of current density with respect to their area itself, right. So what will be the value if it is going to be a little bit inclined at a certain angle? Here what you will find, it is going to be inclined with a certain angle, right, that is theta. So what value you will, if you will take the projection of this one, what you will find, what type of value you will find, its projection itself a state that is going to be inclined at a certain angle theta. So if you will take as a direction of current I, this is going to be inclined at an angle of theta, then you have to go with the concept of what? Their vector representation. So horizontal component of this value will becomes equal to what? You will say that this value will becomes equal to A cos theta, and vertical component will becomes A sin theta. Now listen carefully. I have taken this particular area dA. So if you are taking it as a dA and dA, what you will observe that meanwhile current density value will becomes equal to sin theta component will becomes vanished, right? Because that should be perpendicular to each other, and if you are taking this vertical component, it is not going to be perpendicular to each other. Once it is going to be perpendicular to each other, you have to go with the concept of dA cos theta, that is their horizontal component. Now listen very carefully. That's why this value will becomes, according to this concept, di upon dA dash, because this particular area is going to be taken into the account, and that value will becomes where dA dash will be equal to dA cos theta, right. So again, wait for a minute, you will find that what type of things I am going to be derived from here. It's very quite tough for me, it's very difficult for me to complete this type of board. Here you will find that current density value will becomes equal to dI upon dA cos theta. What is the value of current will becomes J d A cos theta. My dear, now you have to be understood the concept. What concept? It is a vector quantity, right? It's also a current is also a vector quantity. So what value you will take? Can you write in the vector form? It will becomes equal to J dot A, right? J dot not A dA. J dot dA, because J dot dA means J dA cos theta, right? So meanwhile you will find the di. Overall, if you are going to calculate the current density for whole system, what you have to be do? You have to integrate, right? So for here you have to integrate. Once you will integrate the value, you will find that this value will becomes a, and if j is the constant term, you will find that the value will becomes j a dot a vector a, and this is your, from this concept you will find factor j will becomes current per unit area, right? And this is known as current density. So you have understood this concept. After onwards, I will discuss a few types of numericals based on the concept of current density, right? So once I will complete it, I will go with the concept of a few numericals. What type of numericals they prefer with respect to current density. See, suppose if I will ask you a question that you need to calculate the value of electric current through a cylindrical wire of radius r, right? Through a cylindrical wire of radius what r, right? If current density through the wire is uniform, means is trying to say that in my mind I have come with a question that if I am going to take a cylindrical wire of radius r, and if current density value in that one is uniform, that is J is uniform, right? J is uniform. What will be the value of electric current through that electrical through that cylindrical wire, right? So use that one concept only. Here I is equal to J dot A. Now you will say that it is going to be uniform. So J dot A means what? J dot J A cos theta. And theta value will becomes how much? Cos theta value will becomes 0 itself. So J A cos 0. Sorry. Cos 0. Once you have taken the value of cos 0, you will find that it will becomes equal to J A. And what is the area of this one? You can calculate very well. Area of this circular portion will becomes equal to J pi r a square, right? Once you have calculated J pi r square, value will becomes equal to what? I. So value of J will becomes equal to I by pi r square. And in this way, you can calculate the value of current density with respect to the cylindrical wire of radius r, right? Once if Current density value will comes in a form. You can calculate the value of current in it, right? In this manner, so various types of numericals are there in that one. We will discuss it later on. By the way, it's time to switch off the lecture. It's time to meet you soon. Again, let it be. Wait for next lecture. Right? Bye bye.